Hi, everyone. Thank you so much for joining the Azure AD B2C webinar series. Today is our continuation, our second week, with the B2C and app integration with MSOL.
Great, thank you, Sophia. Welcome to part 2 of the B2C webinar series on the Microsoft Authentication Libraries and integration with Azure AD B2C. My name is Jenny Ferris, and I'm an engineer working on the Microsoft Authentication Libraries. Also on the call is our program manager for the Authentication Libraries, Jean-Marc Pierre. He will be fielding questions in the Q&A throughout the presentation. As Sophia mentioned, if you have questions, please put them in the Q&A. Jean-Marc will answer as we go, but we also will have a few minutes at the end to go over further questions. Thank you for joining this live Teams event. We are very excited to have you here. We'll be doing a lot of live demos today, and you're welcome to try out the code samples with me or try them later. I've included an MD file in the Q&A, which has links to the code samples and step-by-step directions. Hopefully, you'll try them out with me. All right, let's get started. Today, we'll do a quick recap of the previous session on OAuth 2.0 and OpenID Connect. We'll look at the scenarios supported by B2C and how the Microsoft Authentication Libraries hide the protocol complexities. And finally, I'll be demoing a few of our MSAL B2C samples, and hopefully you'll join in. So let's start with a quick review of OAuth 2.0 and OpenID Connect. Remember that OAuth 2 is about authorization and getting access tokens to protected resources. The protected resource will validate the access token, which is scoped to permissions accepted by the user or resource owner. OpenID Connect is an identity layer built on top of the OAuth 2 protocol and is about authentication. OpenID Connect enables the client to get an ID token back from the authorization server, which contains claims about the signed-in user. The ID token, unlike the access token, is for the client. There are 3 types of tokens we'll be looking at today. Access tokens give scoped access to a protected resource based on the permissions a user consented to. The access token format is not defined in OAuth 2, so it could be any string value, including XML. However, the format is defined in OpenID Connect to be a JSON web token, also called a bearer token. Refresh tokens can be obtained at the same time as the access token, but allow the client to obtain a new access token without prompting the user. Access tokens are short-lived, but a refresh token has a longer lifetime, up to 90 days. ID tokens contain information about the signed-in user and are specific to OpenID Connect. So let's take a look at a high-level example of OpenID Connect with the authorization code flow of the OAuth 2 protocol. The resource owner or user signs into an application on the client. The client goes to the well-known OpenID configuration endpoint on the authorization server and gets back a metadata JSON document about the authorization server. The client then goes to the authorized endpoint of the authorization server with the response type of code. The user is presented with the sign-in dialog, which takes place outside of the application in a private conversation between the resource owner and the authorization server. If the resource owner agrees to the scopes requested by the protected resource, the authorization server will issue an authorization code back to the client. Next, using the back channel, a secure communication line, the client will exchange the authorization code for an access, refresh, and ID token. The client stores the refresh token in a cache and opens the ID token to display personalized content to the user. The client will send the access token on the back channel to the resource server to access the protected API. The protected API will validate the access token and grant or deny access. If you have further questions about this protocol, please watch the recording from the previous session on OpenID Connect and OAuth 2.0. So as you can see, There is a lot that can go wrong when implementing these protocols, so leave the complexities to authentication libraries, like the ones offered by Microsoft. The MSALs are open source, client-side libraries which are used to acquire tokens for calling protected web APIs. The MSALs follow the OpenID Connect, implement OpenID Connect, and follow the OAuth2 protocol, so no need to directly code against these protocols in your applications. In addition to supporting OAuth2 and OpenID Connect, the MSALs acquire all types of tokens. They also maintain a token cache and handle the refreshing of the tokens for you when they are close to expire. You don't need to handle the token serial expiration on your own either. The only thing you might need to do is handle their serialization. The MSALs have a developer-friendly API, which, in addition to other fine-grained control, enable you to specify the audience, such as your organization or tenant, several organizations, work and school accounts, and even social identities with Azure AD B2C. MSALs also assist with troubleshooting by exposing actionable exceptions, logging, and telemetry. The MSALs are also battle-hardened. The MSAL teams have been working hard over the past year to move internal partners at Microsoft from the previous authentication library, ADAL, to MSAL. For example, Visual Studio 2019 runs on MSAL.net. Another example of a service is the Azure portal and its add-ons, which are running on MSAL, handling millions of requests a day. You can also get help when you need it, either through our Azure support channels or directly on GitHub, interacting with engineering teams and providing feedback. The current supported libraries by platform are JavaScript, .NET, which covers .NET Core, .NET Framework, UWP, and Xamarin, Python, Java, native iOS, and native Android. The type of library you use will greatly depend on the scenario or what type of app you're building. There are 6 scenarios covered by the Microsoft Identity Platform. Single page application, or SPA, which uses the implicit flow, meaning it acquires an access token directly from the authorized endpoint of the authorization server. There is a web app to sign in users, a web API, daemon applications or applications that run in the background or server to server, mobile applications which run on Android and iOS devices, and finally, desktop console apps which run on Windows, Linux, and Mac OS. Depending on your scenario, we have an MSAL for you. Today, we'll focus on the single page application for JavaScript. We'll also run a desktop application, mainly to look at the logs and token caching. And finally, we'll create an ASP.NET Core web app, which calls a web API. So where does MSAL fit in the B2C ecosystem? Here's a user. He or she has a mobile device. On the mobile device is an application which uses an MSAL SDK. The MSAL SDK has a token cache where it will keep the tokens secure and refreshes them as needed. When the user signs into an application, a browser appears, and the user has a private dialog with Azure AD B2C. Azure AD B2C then communicates with the social providers registered for the specified policy. So what's a policy? A policy fully describes identity experience, such as a sign up, sign in, create an account, or read a user's profile. Each policy is a separate authorization server or authority and issues its own tokens. And we will look at this later in all of our samples. So let's look at an example. In this example, a user goes to a web application. They click sign in and are directed to the authorization server of that policy. In this case, the sign up, sign in policy. The authorization server renders a sign in dialog and the user selects Facebook as the account to use for sign in. The authorization server then redirects to Facebook, and Facebook, as another authorization server, presents the user with the sign in dialog. The user signs in with Facebook, and Facebook issues a token to Azure AD B2C. Azure AD B2C validates the Facebook token and reads the claims. If this is the first time the user is signed in with Facebook, Azure AD B2C will create an account in the Azure AD directory for this user with the social AD field of Facebook. If the user is already there, then Azure AD B2C will read the social account profile from the Azure AD directory and issue an Azure AD B2C token back to the client. So once again, the user will sign into the application. They're targeting a specific policy or authorization server. In this case, sign up, sign in policy. They select Facebook. They're redirected to Facebook. Facebook issues a token to Azure AD B2C. Azure AD B2C will validate the token, read or update the user profile, and then issue an Azure AD B2C token back to the application. So to understand this better, let's run through some sample code. I included a markdown file in the Q&A. If you open it, you can follow along, run the code with me, or try it out on your own later. So I'm going to go to the MD file, and you can see here there are a few prerequisites. One is to have Node installed. That's to run the JavaScript web app and web API, and have your favorite text editor ready. I'm going to be using Visual Studio 2019, and then we'll be walking through 4 pre-configured MSAL plus B2C demos or sample code. So if you have a B2C tenant, which is optional, like a test tenant, if you created one, you can supplement the values in the samples and use your own B2C tenant values. However, the samples are pre-configured, so they will run and work as is. So I'm going to start by opening 2 command prompts. I'm going to use one for my web app and one for my web API. I'll go ahead and make a folder. And now I'm just going to git clone all 4 samples. So I'll just copy paste. There's the web API for JavaScript. I'll git clone the web app, the desktop app, and the ASP.NET Core incremental tutorial. And now in the bottom command prompt, I'm actually going to go into the web API. And in the top one, I will go into the web app for JavaScript. And I'll go back to my directions in the MD file. So I'm just going to do an npm install and update in both. And the web API by default is going to be running on localhost. And so I just have to do a few configuration updates in the web app. So I'm going to go ahead and open up the folder where the web app is located. And I'm going to go into JavaScript SPA. And I'm going to open up the API config.js file. And you can see in MD file, it says to replace, I'm going to be replacing the location of the web API. Right now it's running in Azure, and I want it to run locally so that I can actually see the logs in the console. So I'm just going to copy this line with localhost. And then on line 4, where it has web API running in Azure, I'm just going to replace that with localhost and then hit save. So these are my scopes for the API demo.read. Remember, we're asking for scoped access to the web API, and it's going to be running in localhost 5000/hello. Another thing we can look at is the auth config file. We won't make any changes in this file, but I do want to point out a few things. So you can see here I have my MSAL configuration. So I have my client ID. I'm passing in my B2C authority. I'll be targeting the sign up, sign in policy. So this is a separate authorization server. And I also have to set validate authority to false. I don't want, because it's B2C, I don't want it, validation, authority validation is an AAD specific concept. And so for JavaScript at the moment, you just have to set this to false. And for my login request, you can see the scopes. I have OpenID and profile because I'm doing the OpenID Connect protocol. And the scopes I'll be getting from the API config file. All right. So all I have to do is do npm start in both. I'll start the web API first. And the web app is running on port 6420. So I'll go ahead and open up a browser. And I'll navigate to 6420. And this is my web app. So it's running here. I'm going to right click and go to inspect. And click on network. And now I can inspect the network traffic. So I'm going to hit sign in. And you can see it already went to the OpenID configuration endpoint. And I got back the metadata document that we talked about earlier, which explains the scope, the claims supported, what are all of the token endpoints for that particular authorization server. And I'm going to go ahead and sign in. You could sign in with Facebook or Google or Microsoft. And if you're already signed into Facebook, it will sign you in automatically if you have an active session. But I'm going to sign in with a local account. You could also create one by hitting sign up now, and then you'll have a local B2C account. So I'll go ahead and sign in. Okay, and now I'm going to hit call API. So now I'm going to call my API, which is running locally. Right here, we'll look at that in just a moment. You can see here it went to the authorized endpoint. And I passed in response type token. And remember, when I'm doing the implicit flow, which is what we're doing now, I'm combining the first two legs of the OAuth2 protocol. So instead of getting the authorization code back and then redeeming that code for a token, I'm getting the access token back directly. And so I do that by saying response type token. And then you can see I actually have the access token right here. So I got it back directly. If I go back to my console app that's running, so this is my web API, and my web API is using a middleware called passport.js. It's a middleware library, and the middleware library's job is to validate the access token. Remember, the ID token is for the client, and the access token is for the web API. So my web API will validate the claims in the access token, which is what it's doing down here in the part in green and yellow. It's checking the issuer, the expiration, the audience, and making sure that this access token has the right scopes. You can see the scope value at the bottom for this protected resource. So the nice thing about the JavaScript library is that you can actually see the passport library. Here's the access token coming in. It's using the bearer strategy. It's a bearer token because bearer tokens are JOT tokens. That's how they are defined in OpenID Connect. So think of a bearer token as I find $10 on the street. I take the $10 to the store and I buy some candy with it. And I don't have to prove that I'm the owner of the $10. Just the fact that I'm possessing them, I can use them. So the bearer token is the same. Because my web app has a token, a bearer token, it can be used with the protected resource. It doesn't have to do any additional validation to prove that it can use this token. But the web API will do the validation on its end and make sure that this token is valid to access a protected resource. Okay, so that is the JavaScript sample. I'm going to go ahead and close these because they might interfere with the next demos that also run in similar locations. Okay, so that was a MSAL.js single page application running with a Node.js web API and using the implicit flow. So now we're going to look at an MSAL.NET desktop application. And this application will actually be doing the authorization code flow, which is what I showed in the diagram earlier. So first, we'll be asking for an authorization code, and then we'll be redeeming that code, or MSAL will redeem that code for access, refresh, and ID tokens. So if you go back to where you have all the samples stored, I'm going to open up the desktop application next. And you can see in the MD file, we're going to put a bunch of breakpoints in the code. Before you do that, you'll probably have to rebuild just to make sure all the NuGet packages are restored correctly. But we're going to add in breakpoints so that we can go through and see some of the code as it's coming in from MSAL. So I'll go ahead and rebuild. And I'm going to open up app.xaml.cs first, just to show you some of the configuration. So you can see here we have the tenant. It's our Fabricom, just our B2C testing tenant. It's using b2clogin.com. We have the client ID, and then we're targeting 3 policies with this application. There's the sign up, sign in policy, the edit profile policy, and password reset. And B2C allows you to do custom policies and custom user flows, but we're just using the default out of the box policies, which are these 3. Then we have our API scopes. So we're targeting the same API that we used in the JavaScript application, but this time I'm just going to let it run in Azure. And so the scope for that is demo.read, and this is the API endpoint. And then you can see I create my B2C authority, and I have 3 different authorities. I have an authority for the sign up, sign in policy, an authority for the edit profile policy, and an authority for password reset. And the reason for that is because each policy is a separate authorization server. So think of them as completely separate. Each policy will issue its own tokens. So sign up, sign in policy is a separate authorization server from the edit profile policy. Then I'm going to use MSAL to create my public client application. I will give it the client ID. I will say with B2C authority so that MSAL knows that this is a B2C authority. And then I'm going to include some logging. Earlier we talked about logging. So the MSAL libraries provide developers the opportunity to use logs to see what's happening. And we'll look at the logs when we're done with the application. And then I'm also going to have a token cache. And I'll look at that in just a moment. So here's where I have the logging set up, and I'm actually just putting them on disk in a TXT file. So pretty easy. And then if I go to the token cache helper, I'm going to be protecting the token cache with DP API, and they're going also on disk in this file here. And MSAL will handle everything else for me. Refreshing the token is needed, so my users don't have to sign in again. So we'll look at that once we run the app. So I'm going to open main window, and I'm going to add in the breakpoints. So line 27, line 56, 92, 158, and 193. Okay, so I'll go ahead and hit start. So the interesting thing with this desktop application, we have it set up so that when the application loads, it's actually going to check the cache. So I showed you the location on disk where the MSAL cache is stored. So it's going to check the cache and see if there are any accounts in the cache. And since this is the first time that I've run this app, I just did a git clone. As expected, there are 0 accounts in the cache. I haven't signed in yet. So I'm going to go ahead and hit continue. There we go. Okay, so here's my little desktop app. I'm going to hit sign in. And here I'm having a private conversation with the authorization server. I'll go ahead and sign in. Okay, and I got back an ID token, which the client has validated and opened, and it's presented some claims to me, like my city, my job title, my email, and then which identity provider or authorization server was used to get these claims back. But let's say I don't really like what this says for job title or my city, so I want to edit my profile. So I'm going to click on Edit Profile, and it says to send a code to my phone. So let me wait for that. And I've got the code, it's 382410. Okay. Okay, so now I can edit my profile. So I could change my display name. Maybe I'll change my city to Seattle. And my new job title is cat sitter, as I'm home all day with the cats now. So I'll hit continue. And if I wanted to have more information here, I could ask the customer for more fields. I could have them complete more information. But I just have display name, city, and job title. Handling the content displayed here is done in the Azure B2C portal. So I'll hit continue. And now we're back in the application. You can see when the edit profile button was clicked, I'm actually going to use, as a developer, I'm going to do an acquired token interactive call, because there's a UI dialog that has to be shown to the user. I have to edit my profile. So I need Azure AD B2C to render some kind of UI. So that's why it has to be an interactive call. I'm doing a with B2C authority, and I'm passing in the edit profile policy because I'm no longer targeting sign up, sign in. I'm actually targeting edit profile, and it's a separate ticket issue or token issuer, separate authorization server. But now I've included no prompt. And the reason I have no prompt is because in order to get to the edit profile policy, the customer has to have previously signed in, either signed up with my application or signed into the application. And so I don't want them to be prompted another time, because then they would have to enter their credentials and their password again and then edit their profile. But they just did that. They just signed in. So I'm going to send no prompt. And what no prompt does is it tells the authorization server, so Azure AD B2C, hey, if you have an active session for this user, please don't render them the sign-in dialog or the UI dialog to sign in. Just let them sign in and have the edit profile policy page shown directly. And so since I did just sign in and I have an active session with Azure AD B2C, I went directly to the edit profile page. And then you can see in the auth result that I get back from MSAL, I have my access token, which I'll need later to send to the web API, and I have an ID token. And if I open this ID token, and I go to jwt.ms, I can paste the ID token here, and then it will decode it for me. It will show me the header, the body, and I can see what the issuer was, the claims. And if I'm not sure what these values are on the left-hand side, I can click on claims, and it will give me a description in the notes of what those values are. And you can see down here, I have my updated claims, Seattle and cat sitter. Also in the authorization result, you can see I have an account. And the account is what's going to be used by MSAL on the token cache to make sure that it's retrieving the correct tokens when needed. So you can see this token is going to be under the edit profile policy. So now I'll have an edit profile policy token in my token cache. So I'll go ahead and click continue. You can see my updated claims here. And now I'm going to call my web API. And when I call the web API, my web API is actually protected behind the sign up, sign in policy. it requires the sign-up, sign-in policy to access the protected web API, because I want to make sure that my customers have already signed in or signed up to my application before they access the protected web API. So in order to get to the web API, I need the sign-up, sign-in token. So you can see here I have 2 accounts in the MSAL cache. I have one for the sign-up, sign-in policy, and I have one for the edit profile policy, but I need the sign-up, sign-in policy. So the policy that I'm passing in is sign-up, sign-in, and then it will filter through the MSAL cache and pull out the correct policy to then use with the protected resource. So I'll hit continue. It's found the token. Here's the access token. Remember, I got the access token back in the authorization result. And now what I'll do is I'll just append that token to the header with bearer, as we saw in the passport.js logs. You saw where we had to include the title bearer to identify what type of token it is for the web API, and then append the token. So that's what's happening here. I'll hit continue, and then I get my name back from the API results, as we saw in the JavaScript sample as well. So now I'm just going to close the application, and I'm going to start it again. And I didn't sign out. So now when the window loads, I should have something in the cache, and I do. I have 2 accounts still. So my first account I have for sign-up, sign-in policy, and my second account is the edit profile policy. So because I didn't sign out, MSAL kept the token cache, and as long as I have a valid refresh token in the cache, it will do an acquire token silent. Acquire token silent just means that the user will not be shown an interactive dialogue, so there will be no UI displayed to the user. MSAL will try to silently sign me in, and all it needs to know are what are the scopes that I want, and then what is the actual policy for the token, because I have 2 in the cache. So it's going to look for the sign up, sign in policy. And then I should just sign in automatically without getting a UI. And I did. You can see that I signed in, no UI. I'm already signed into the application, and I could call the API now or edit my profile. I don't have to sign in again. But now I'll go ahead and sign out. I'm going to sign in now. So you can see the token cache was cleared, and I have to sign in now. But let's say I forgot my password. So I'm going to click on forgot your password. And this is some special magic that B2C developers need to include in their applications, but that Azure AD B2C is actively working to fix and resolve for you. So the current experience right now, when a user hits the edit profile or change my password, you have to, as an app developer, direct them to the edit password policy. So you have to catch this error coming back from MSAL, which says the user has forgotten their password. And then you'll need to do an interactive call, because the user will need to be shown a UI so that they can change their password with the correct scopes. You would probably want to do select account so that they can actually pick which account they want to change the password for. And then the authority is password reset. So B2C knows this is a developer pain point, and they're currently working on bringing the password reset policy under the sign up, sign in policy, so that this password resetting will be handled on the server and no longer on the client. So if a user wants to go in and change their password, B2C will handle that on the server side, and you won't have to worry about catching this error message. But for now, this is the developer experience. So I'm going to go ahead and stop this. And I'm going to go back to the folder where my application is, and I'm going to go into bin debug. And this is in the MD file. And you can see this is the token cache right here, protected by DP API. I could delete it right now, and then I would have to sign in again, even if I didn't sign out of the application. And then these are the MSAL logs. So this is for the entire time that the app was open and being used. MSAL was collecting logs behind the scene. And I can look for, oops, if I spell it right, authorize, and you can see here an authorization code was retrieved from the authorized endpoint. So this is where MSAL was starting the first leg of the OAuth2 protocol. And then it says exchanging the auth code for tokens. So then it took that authorization code and exchanged it for tokens. So the nice thing with the logs is it really goes step by step what MSAL is doing so that it's not hidden from you. You can also provide your own correlation ID if you would like, so you know exactly which requests are related and which ones are not. And if there's errors, you can search for that as well and see where exceptions are thrown. So the logging feature is very nice. All right, but what if, so we've looked at MSAL JavaScript and a Node.js web API. We've looked at a desktop application, but what if I want to create an ASP.NET Core web application which signs in users with social accounts? So today I can do this easily with templates available in Visual Studio. In Visual Studio 2019, I can go to create a new project and then select an ASP.NET Core web application. I then click Change under Authentication, and then select individual user accounts and connect to an existing user store in the cloud. And here I'll add all the necessary values for my B2C tenant to create a B2C web app which only signs in users. This ASP.NET Core web app only signs in users and only completes the first leg of OpenID Connect, which is getting the authorization code. It could also redeem the code for tokens, but this would only be for one web API and it would not be renewed. So if I want to reliably call a web API or access a protected resource from this web app that I just created with today's Visual Studio templates, as a developer, I would need to do several things. And the links to the code examples are here. I'll go through this quickly because you don't need to do this anymore, but I wanted to show you how the experience is different now. So all the code that you'll need for the application developer, you'd have to write in order to reliably call a web API from the current Visual Studio web app template experience. So first, I have to handle the auth code in startup.cs. This involves overwriting the OpenID Connect on authorization code received event. Then I would need to use MSAL.NET. I would have to create use MSAL.NET to create a confidential client application, which I would then use to redeem the auth code for tokens. Next, I'll have to do some token cache serialization, so my web app can use the access token to call the protected resource. But there are some complexity issues with this for security and performance implications. For example, I want to make sure if I'm doing a web app that I only have one cache per user. And also my serialization depends on my needs. I could have an in-memory cache, a database, or a Redis cache. And then finally, I have to acquire the token in the controller by doing an acquire token silent call with MSAL, which will guarantee getting the token I need and refreshed if necessary. And I'm sure you're thinking, but we said this was going to be about making authentication easier for developers. Well, Microsoft heard your pain and feedback, and we just published a beta version of Microsoft Identity Web, a new library. Think of it as MSAL for web, which provides the glue between ASP.NET Core, which obtains the authorization code, and MSAL.NET, which obtains the tokens and provides a token cache. Microsoft Identity Web, or the glue, enables developers to take advantage of token cache storage, scope validation, and works with the ASP.NET Core middleware to make calling a web API from a web app much more developer friendly. It also provides a workaround for same site and provides claims validation methods to build secure web APIs. So let's do just that. We're now going to build an ASP.NET Core B2C web app, which calls a web API. So if you go back to all the samples that you've downloaded, now we're going to be using the ASP.NET Core web app OpenID Connect v2. And the nice thing with this project is that it's actually a series of incremental tutorials. So it starts from a web app OpenID Connect. So this is just signing in users, and then you can sign in a user and call graph, and then sign in a user and call multiple APIs, and then sign in a user and call your own API. And the tutorials go from gradually more basic to more complex. And so we're going to be starting with your web app, your API. So file 4, and we're going to be doing B2C. Okay, and because this solution is running both the client and the service, or the protected API, I'm actually going to right-click and go to Set Startup Projects. And I'm going to select multiple startup projects because I want both of them to run. Okay, so we'll look at the client first. If I go into startup.cs, remember where I showed you, I think it was maybe 5 slides of code you would have to add to your web app in order to call reliably a web API? Well, using Microsoft Identity Web, now all you need to do is add sign-in and pass in the configuration, and then specify what the name of it is in appsettings.json. In this case, it's Azure AD B2C. Then I'll do add web app calls protected web API, and I'll pass in again the configuration. And this time I'm going to give it the scope of the web API that I will be calling. And then I can add an in-memory token cache. And that's it. So I went from 5 slides and down to very little code. I'll show you a little bit more. In services, to-do list service, using dependency injection, I'm going to get the token acquisition, which is coming from MSAL. And I will use that in prepared authenticated client. So here I'll do get access token for user, and I'll pass in the scopes. And then I will have the access token. So this is where Microsoft Identity Web is now leveraging MSAL, and I can send it in as a bearer token in the header. So much less code for you as a developer to have to write. If I go down to the service and startup.cs, now for the service, all I need to add is add protected web API and pass in my options as well. Okay, so we'll go ahead and run this. It's coming. Okay, so here's the same sign-in dialog that we've seen before. And remember, all of the elements on the sign-in dialog are fully customizable. It's just HTML. So that's a nice thing with B2C is you can customize the sign-in experience. This is just the default experience. And again, you can sign up with Facebook, Google, or Microsoft. I'll sign up with my local account. Okay, and I've signed in, and now I have the option to edit profile. This is just part of our sample, and I'm actually going to call the web API because this is what we wanted to show you, how much easier it is to now go from a web app, .NET Core web app, to web API. So I'll call the to-do list service, and this is just a list like literally of things to do. So I'm going to create a new item, and I'm going to put feed the cats second breakfast. Okay, and I can be the owner of it. And then I don't need to pick up groceries. I delete that. Yeah, delete that, and invoice report, I'll delete that. And then I can sign out. All right, so that is an ASP.NET Core B2C web app calls Web API using Microsoft Identity Web, which we just released 2 weeks ago as a beta package. Okay, so I believe that Sophia will be posting the feedback link in the Q&A. If you want to take a few minutes to complete that survey, Jean-Marc and I will take a look at any of the questions coming in if we'd like to discuss those with all of you versus typing them into the chat window. And thank you so much for attending today. We hope that this gives you a good start on how to integrate your applications using the Microsoft Identity Platform and Microsoft Authentication Libraries and B2C.
Great, so I just posted the post-call survey in the announcements now, so if everyone can take a minute or two to fill that out. But in the meantime, if Jenny, you and Jean-Marc want to turn it over to questions and anything, Jean-Marc, that you saw throughout the session that you want to bubble up as well.
Jean-Marc, someone asked an ETA on when the glue becomes GA. Since you're the PM of that project, do you want to answer that?
Yes, and you are the engineering lead of that project. Yes, so yeah, I was typing, but I will say the answer verbally. It's a release which will be quality based. So that means that when we're sure we won't modify too much the public API because we don't want to break you, and that the quality is here, we will GA. I mean, it's a bit up to you to tell us you think it's good. If you look in the GitHub repository, there are a number of issues which we have tagged with API breaking changes. So you probably don't want us to GA before we have processed them, or at least decide if we do them or not.
Yes, I think we're trying to get more feedback from developers and also from the ASP.NET Core team before we, we don't want to, like Jean-Marc said, GA and then have public breaking changes. But please give us the feedback. It's in the Azure AD Microsoft Identity Web is the GitHub repository.
And also in the future, the ASP.NET Core templates will use Microsoft Identity Web instead of the Azure AD UI and Azure B2C UI. So that you know. Okay, so how is it different using B2E or B2C or B2B? Is there any difference in the code, either using MSAL or Microsoft Identity Web? So with MSAL a bit, with Microsoft Identity Web, that's the same code. We haven't done anything. I mean, we are hiding the details with Microsoft Identity Web, which is only for web. With MSAL, you have a slight difference, which Jenny showed about the fact that each policy is really corresponds to a different IDP for the moment. So that means the authority is different. It's a different authority, which is for a given user. If you are account, if you use different policies, there will be different tokens. So you have to do a filter by policy. That's what when you do MSAL. With Microsoft Identity Web, we are hiding the difficulties normally. Can B2C access token used to access Azure Blob Storage with airbag settings? I don't think so. I think B2C applications, maybe John can tell me more, but B2C applications, they can access your own web APIs. They cannot access Microsoft APIs or Microsoft resources yet.
Yeah, Jean-Marc, also with that one, the blob storage RBAC is governed by the Active Directory that manages the Azure subscription and by the tenant, whereas B2C would be a separate AD special B2C tenant. So the identities in the B2C tenant would not be able to be assigned to the RBAC permissions in the Azure subscription that contains the storage account.
That's for today. We are well aware of these kind of scenarios, and you can imagine that it would be good to have a kind of convergence between both. I won't say more. Can the access be restricted? Yeah.
So I was going to read it. Go ahead.
Okay. Can the access be restricted to only certain users using the ADB2C? Yes. Once you have the if I guess web apps or web API, or because so it can be restricted. You can decide which IDP wants to send in users, and then when you are in the web app or web API, you can always look at the claims and do some filtering and reject if you're not happy with the user. If I create the storage account in Azure AD B2C tenant, I don't think that is possible. The Azure AD B2C tenant is a resource on its own. I don't think it's possible. how is SSO experience how SSO experience will look like with other apps? Will it work for Office apps or other apps? So here we are talking of signing in users with B2C in local accounts or with social identities. So you have SSO with your social identity. So in other words, if you give me an example, you are you use a browser and you go to your Gmail account. Then when you sign into a B2C application and decide to sign in with your Gmail account, then it will know it already because the browser knows it. So will it work with Office apps or other apps? Office apps are not, to my knowledge, using social identities yet, or I don't know if that would be the case. So they are more using Microsoft identities, which means work or school accounts or Microsoft personal accounts, live accounts.
And just to add on to that, if you're an iOS either native developer, Objective-C, or doing iOS Xamarin, you can set the keychain with MSAL.NET and with Objective-C MSAL. So you can say if you're publishing your apps under the same publisher, then they can share keychain access. So if you're not using the system browser and you want your customers to have a nice sign-in experience, if they've already signed into one of your applications, they can sign into the other and share the keychain if they're under the same publisher. And that's how it works with Office apps, because they're all under the Microsoft publisher. And if you as a company have your own keychain access publishing, you can use that and set the keychain access using the MSAL libraries.
Great, so we have about 2 minutes left. So I think we have about time for 1 to 2 more questions before wrapping up today's session. I just wanted to thank everyone for joining today. Are there any final questions that we've seen that have come in, or is now a good time to wrap up the session?
There is one question. Oh, okay, no, it's answered. It's the SSO one, which I. Not many questions today. People are shy. Yesterday night, that was a lot more.
Great. Well, I just want to thank everyone for taking the time to dive into today's session to attend, and Jenny and Jean-Marc as well. Thank you so much for jumping on today's session.